Dear students, welcome to our class on Numerical Weather Prediction 2. In this class, we try to understand after a brief introduction, numerical weather prediction development work in India, how it has developed in our country, and numerical weather prediction operational system. So, what is the operational system? So, before that, in the introduction, I would like to impress upon you once again that the basic definition of the fundamental course of what is weather forecasting. Weather forecasting is the predicting the weather for the next few days to follow is known as weather prediction. Now, in the numerical weather prediction. So, what is the numerical weather prediction? It is a method of prediction. There are several methods. It is one of the methods of prediction. By what? By numerical. By arithmetic, mathematics. Okay. So, numerical, that means mathematical. So how we do it? First we go for some set of equations. Okay, in the first class we discussed set of equations, different. So conservation of mass, conservation of momentum, conservation of heat, conservation of energy, the basic gases, so set of equations. Then we go for numerical methods. So basic derivatives, basic derivatives of weather systems, they are converted into equations and computers run and they give us the numerical output. So, and in a graphical form also we get finally. Now, so third step involved is the parameterization. We discussed thoroughly in the class 1. And initial and boundary conditions we take it. So, by taking the equations, employing the numerical methods, by going for certain parameterization, finally we get the and by adding the initial and boundary conditions, we get the output in the form of numericals, and then we get a graph also. We have in the operating system I will have. So not only graph we get it, we can archive it. Okay, and we get to do so many, by using so many models, not only what different models, and we get EEM. Okay, EM. That also we discussed in the class 4. Now it is class 2. So now what I would like to say very straightforward is that the numerical weather prediction is a method in which mathematics or numericals are basically used. And high power computers are used to give the output of weather. We get what we want. It is only what is going to happen, whether it is a short range forecast, whether it is a nowcast in the short range forecast, medium range weather forecast, or extended range weather forecast, or long range weather forecast, whatever it may be. So we just try to understand now. In this class, after this brief introduction, let us see what is the development work in India with reference to numerical weather prediction that I would like to share with you. See, currently weather forecasting services are based on both conventional synoptic and supplemented by numerical weather. Currently, synoptic observations are there. Traditionally, we are very, very strong. Okay, India has a wonderful network of surface observatories, whatnot. So radio, sound, nowadays, radar, satellites, so non-conventional, sources of information is also there. Now, so that, and then we use numerical weather in conjunction with them. Okay, we go for numerical weather prediction. So, application of computers for the numerical weather prediction started. Application of computers for the numerical weather prediction started in India in the early 1960s. So, okay, during the International Indian Ocean Expedition, IIOE International, of course, Indian Ocean Expedition with IBM 1620 computer. As early as 1960, IMD started using the computers in the numerical weather prediction with the availability of IBM 360 by 44 at University of Delhi and CDC 3600 computer at the Tata Institute of Fundamental Research, Bombay. With these two, the development work in India got initiated. So we have two computers, one at IIT, University of Delhi. Second one is the Tata Institute of Fundamental Research, Bombay. So with these two computers available, the numerical weather prediction slowly started its momentum, way forward. Then computer programs for objective analysis of meteorological data were deployed. Computer program, first computer program, when I learned computer program, Fortran language was there. Most of the scientific at that time, for Fortran I learned. Now, see, computer programs. See, actually, I would like to share with you one wonderful thing. When I started learning this computer, DSAT, Decision Support System for Agro-Technology Transfer, that is crop growth modeling. There are different models, I always think that even today the best one is the DSAT for crop simulation. Okay, including they have wonderful options. Several crops, whether it is cereals, pulses, oilseeds, what commercial crops and everything. Yeah, excellent information is available in the DSAT. See here, just to give you a brief advantage of DSAT, please try to learn it. My strong recommendation as agrometeorologist and to my beloved students is that learn DSAT. I am not undermining other things. No. Other things are also more excellent. But agriculture meteorology, please go for DSAT learning, and all others also, please learn all others also. I am not undermining any hard work of wonderful scientists. There you have options for even deterministic techniques. What is a deterministic technique? I have discussed it in the fundamental course. Say a student is there. We write his name, his date of birth, his age. That's the date of birth. We give his previous marks, and we assign him an ID number, and then what marks he is getting in the midterm, what marks he is getting in the quizzes, what marks he is getting in the practical final exam, what marks he is getting in the theory final examination, and reducing it to some percent. All these things, if we give for 100 or 1000 or 10,000, finally we get a good hall ticket with name, ID number, OGP, etc. Am I right or wrong? So such things are such is the power of deterministic model. So why I am telling all these things here is that try to have faith. Numerical weather prediction models are the best as of date. Okay, for weather models. Now, so let us see. Experiments with barotrophic and quasi-geotrophic models and diagnostic studies were carried out later on. Okay, after 1960, then two computers, one in University of Delhi, one in Tata Institute of Fundamental Research. Then computer programming started. Then experiments with barotrophic and quasi-geotrophic models and diagnostic studies were carried out. Then with the installation, this is a major breakthrough. This with the installation of IBM 360 by 44 at IMD New Delhi in July 1973, the work in the numerical weather prediction field progressed fast. 1973, this is the breakthrough. IBM 360 by 40 was established in IMD. Now, single level, 3 level, 10 level, and multi level. I tell you, single level, 3 level, 10 level and multi-level, non-linear balanced model was developed. Models were developed for diagnostic studies in tropics. Ours is a tropical dominant soil. Indian summer monsoon is a part of the Asian monsoon. Okay, that's what I told. Indian summer monsoon is a part of the Asian monsoon. There, what is very, very important is depressions, cyclonic depression, lows, atmospheric lows. These play an important role in the progression. Another thing is Equatorial Trough. When it is reaching foothills of Himalayas, we get the lull in the monsoon or no rainfall. When it shifts towards the south, copious amount of rain. All these things are being studied from several years and by using the computers in the numerical weather prediction. Now, see, multi-level, that's what I told. Single level, 3 level, 10 level, and multi-level models for short-range prediction of flow pattern in the lower troposphere were developed and put in experimental use. Lower troposphere, there are troposphere, stratosphere, mesosphere, ionosphere, and exosphere. Lower troposphere, 5 kilometers and less, where Equatorial Trough, lies 5 kilometers. That important fact is also taken into consideration. And in the year 1990, after 1970, another major breakthrough in the year 1990, a study on monsoon prediction at a different resolution with the global spectral model. GSM. Were carried out. So then, mountain wave problem, addressing the properties of the mountain waves over Indian region was studied by many scientists. So wonderful scientists are there. It is my fortune. Few of them are my own colleagues who have just recently retired, are still in, of course, they are juniors to me, they are still in the service in the Indian Meteorological Department. They are going to occupy better pay, highest positions. So they have, one of them have studied the mountain wave problem. That's what I would like to enlighten you. Now, so LAM, this is very interesting, limited area model, and LAM, limited area model. As far as numerical weather predictions are concerned, they are the best in the limited area model. The best. We go for grids. Number of grids, we can go for large scale. But they are based on that. That's what I told. Equations of momentum, mass, energy, basic gas loss. So limited area, wonderful they give. So limited area model was extensively used in research and development mode and for operational forecasting. Yes, as I said, Walker. In the history only, as I said, Sir Walker, okay, 1910 to 1923, okay, 1910 to 1923, just well before these computers have come. So many oscillations he has taken at the global level. To my knowledge, southern oscillations he has taken into consideration for weather forecasting. It is a service. It is a mandatory service of IMD to give the weather forecast. So he made it. So that's what. Now, before that, of course, Sir Bradford, everybody was there. But I would like to impress upon you only with the information, nothing more than that. Now, in view of the importance of this data in tropical numerical weather prediction, continuous efforts are being made by numerical weather prediction community to maximize the utilization of various non-conventional observation. What are the non-conventional observations? Using of the radar, using of the satellite, ships and everything. Okay. Now, see, because this bit will come. Please note that the major problem in the use of numerical weather prediction model over the tropics is the near absence of data about the large oceanic region. This is what I told in the monsoons also. In the large oceanic region, we do not have much of data. So that's why. So non-conventional observations are nowadays used in the numerical weather prediction. That's what I would like to impress upon you. Positive impact of these non-conventional observations from Indian satellites was demonstrated in the analysis and forecast of a limited area model. So the positive impact was seen. It was analyzed. It was seen by using the limited area model forecast. Non-conventional observations were also used. This is the history we are discussing. In two more points are there. So please, 2 bits will come here. Please understand. As far as the Indian monsoon is concerned, particularly Indian summer monsoon is concerned, differential heating of land and ocean. This is a foregone conclusion. Now, convection plays an important role here. So, cumulus convection, this bit will come, where whenever, representation of precipitation process in the numerical weather prediction models, representation of precipitation process in the numerical weather prediction models is known as cumulus parameterization. Cumulus parameterization. Why parameterization? I discussed in the first class. I discussed now in this class. So parameterization means flattening. That process which we do not know thoroughly, which has a large impact, maybe very, very short, maybe very, very brief, maybe very, very big, like cumulus parameterization. We go for parameterization. So this bit will come. What is the bit? Representation of precipitation process. Representation of precipitation process in the numerical weather prediction is known as cumulus parameterization. This bit is certain in the jar of SRM. So take this from me. Now, so let us discuss after this brief introduction. Early 1960 to present. Okay, this is the brief history. Of course, EEM, that's what we discussed. MM is, multimodal ensemble. MM is multimodal ensemble techniques are also used. That we discussed in the class 4. This is only class 2. Now, so let us see what are the numerical weather prediction operation system in a very brief way. Even in the 3rd class also we discussed the operational system. That only a brief I would like to share with you. The operational system of numerical weather prediction is a complete suite of jobs jobs, complete set of equations, otherwise suite of jobs on a high performance computer. So many jobs are done on a high performance computer, number one. Number two, it is centered around the data assimilation scheme. We take the data, whether it is synoptic data, whether it is conventional, whether it is non-conventional, data assimilation we take into consideration. So most important is, very most important point in the operation system in this class I would like to discuss with you is that other essential components are, what are the other essential components? They are the database of the decoded observations. We get the observation in the coded form, okay, decoded observation. Quality control, we need to see the quality. And pre-processing of observations, we get the raw observation, we have to pre-process them. Then database of the post-processed products, database of the post-processed products in the numerical way, and including graphical. Please note that we get a graph. Digital output we get it, dissemination we get, and finally verification also we can do it, and we can archive it. These are the things I would like to impress upon you that see, in addition to initial or boundary condition, everything, database of the decoded observation, database of decoded observation, quality control, pre-processing of the observed data, okay, observational data, pre-processing. That's what we get from the different centers, surface observation, pre-processed data, database of the post-processed products, including 4 are there, including we get the graph, we get the digital output, we get the dissemination process, verification, and finally we can archive it. This is the numerical weather prediction operational system. I just continue for one more minute with a very good bit that would appear in the your SRF, or even when you are asked to write something about numerical weather prediction. 2 to 3 important points are there. All numerical weather prediction models in operation used today solve a form of primitive equation. That's what we discussed. In addition to the main thermodynamic variables, humidity variable is also added. In addition to thermodynamic variables, humidity is also added. The equations are inherently complex. They are inherently complex, and they are non-linear also. In my visits, I understood they are inherently complex, they are non-linear also. They are never linear, non-linear as well. Now, operational India Meteorological Department runs 4 regional models. Number 1, LAM, local area model, okay, at 75 kilometers horizontal resolution. Second one, MM5 model at 45 kilometer resolution, WRF at a 27 and 9 kilometer resolution, and finally I am telling you this bit will come, please write QLM, quasi-Lagrangian model, QLM quasi-Lagrangian model, which is used for cyclone track prediction. This 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 bit is 100% to appear in your exam. Finally, the IMD also makes use of numerical weather prediction models of global models. In addition to our own, we use those models also to give forecast. So this is what I would like to share with you as far as numerical weather prediction development, and just introduction with reference to numerical weather prediction operational system. We continue operational system in the 3rd and 4th classes as well. Thanking you for your very patient hearing.